daily space weather show, just bringing you the most detailed solar imagery and most comprehensive daily space weather you'll find in the known universe. That's a 48-hour video. The previous ones we were showing are all 24-hour videos from SDO, the Solar Dynamics Observatory. And yeah, it's a good time for space weather as we get closer and closer to solar maximum. If you're spooked, sorry? Don't be spooked of space weather. We'll take a brief look at Earth weather here, starting with volcanoes and earthquakes. So Suwanosejima is erupting, Luatobi, Luatolo, Semeru, Merapi. Located in Indonesia, 15,000-foot ash plume there from Merapi to Kono, Popocatépetl, 20,000-foot ash plume there, flight level 200, Sancho Guido, Fuego, Nevado de Ruiz, Revenador, and Sabancaya all erupting. Also, an earthquake drought is continuing, so keep in mind that earthquake droughts end in large earthquakes, right? So just be aware of that. 7.0 magnitude or greater earthquake drought continues, folks. So, again, those end in large earthquakes. An earthquake drought is currently occurring. These are the quakes of note for the past 24 hours. We'll cite those of a 5 or greater magnitude. If you're in an earthquake-prone zone, make sure you're on alert. Take note of earthquake activity, as it could be a foreshock like this 5.3 in Indonesia might be a foreshock. That was from 7:06 this morning. Then Philippines had a 5.3 at 9:29 Universal Time. Japan had a 5.1. The Owen Fracture Zone had a 5.9. They're in the northwestern Indian Ocean. And besides that, well, that's it. Those are the quakes for the past 24. Next, we'll take a look at another 24-hour video here from SDO. There's the 171 angstroms wavelength. It's the house favorite. New sunspot has risen there in the southeast. It's fairly modest. We do have some likelihood of large solar flares, both down there and in the northeast, and some other groups right in the Earth-facing portion of the solar disk. We'll get to it in just a moment. For stuff like the radio flux, so the 10.7 centimeter radio flux is now at 153 solar flux units? 153, I think, is the radio flux. There it is in the 1-year graph, represented by the black line. The black line, the radio flux. Red line, sunspot number. Blue line, AP index. Looks like NOAA's forecasting a little bit of geomagnetic unrest tomorrow night. Maybe they've started watching our channel. Shout out to the National Oceanic and Atmospheric Administration, NOAA. Are you watching our videos, NOAA? Well, good call. Good call. Forecasting some geomagnetic unrest tomorrow night. Is it because of that series of CME impacts we talked about yesterday? See yesterday's Daily Space Weather video for details on that, if you haven't already done so. By the way, if you like the music, it's Golden Cat Productions, my music label, really, that I launched back in the year 2000. And let's take a look at Earth's magnetic moment from space. So we do have a little bit of small solar wind perturbations happening at the moment. They're very minor, and this is what the magnetohydrodynamic pressure is likely to look like for the past 4 hours. That's basically what a proton experiences if it shows up in Earth's magnetosphere, our geospace magnetosphere movie. Here are ground magnetic perturbations as well. And pardon my voice, it is diminishing as the day wears on. I'm becoming less and less likely to continue to be able to talk. So there are the past 4 hours of Earth's magnetic moment from ground level. And here are the data about KP index. KP2 is the current situation. Let's keep this thing short. It's Friday. And congratulations! You've almost survived another week. Solar winds next. First, the ACE. There you go. About 2 protons per cubic centimeter at only 340 kilometers per second. The Discover's next. A little more dense there. Oh, only 1.5 protons per cubic centimeter at about 436 kilometers per second. So pretty weak solar wind there on both spacecraft, which orbit Lagrangian point 1, the gravitational equilibrium point in between the Earth and the Sun. It's about 1 million miles away, the ACE and Discover. There are our GOES magnetometers, and you can see a little bit of space weather happening there with those spiky readings around midnight local time for the Agos 16. That's what the red M stands for, that red M right there. That is midnight local time for the satellite. Continuing on to our heliosphere data, there is our line of sight, our top view ecliptic plane field plot. And Earth is about maybe 12 hours, maybe 16, 18 hours from a sector boundary crossing. Earth is imminently going to move into a South Pole-oriented magnetic sector, as you can see there. Next, our line of sight plot. And if you don't know what it depicts, leave a comment and ask our viewers. Maybe they'll help you. And if you're new to the channel, press the subscribe button. Congratulations on realizing the Daily Space Weather Show exists. Here is our line of sight coronal hole plot depicting the solar B field and coronal holes. Which brings us to coronal holes. How about if we take a look at those from the SDO? There you go, there's 211 angstroms, and it's pretty nominal right now. Once again, there's the animation. Next, sunspots. Sunspot number just over 120. 121 sunspots, 121, 122, something like that is the current sunspot number according to Rob. Next, our flare probability monitor and scoreboard. And we do have some complexity here, especially sunspot 3595, sunspot 3590, and this new group. So, also 3598 is looking like it's got some promising magnetic fields. We'll show those in great detail toward the end of the video. Here are sunspots from SDO Continuum. That is a 24-hour video at 30 frames per second. Next is some more data, like the proton flux, which is flatlined, although we do have a high likelihood of a proton flux spike. Proton events are likely with that sunspot 3590 right on the limb like that, so don't be surprised to see a spike in the proton flux in the next 24 to 36 hours. As far as the X-ray flux goes, it's simmered down a little bit. Background flux is around C1.23. A C1.25 is the X-ray flux at the moment. And before we get to star charts, we'll show 94 angstroms, another 24-hour 30 FPS video from Solar Dynamics Observatory. And, oh, I guess, there we go. That's better. Now you can see it. And now to a star chart. So, star chart, that's what's going on overhead Lehigh Valley, Pennsylvania. You've got Jupiter up there, and you can expect it to stay there for a couple of months yet. So, Jupiter in the early evening sky, if you're in the northern hemisphere, that's what's above our head. Here's our solar system forecast. That's where things will be in 1 week. And if you think planetary alignments are deciding your fate, you need to take more control over your life, because planetary alignments aren't doing jack to you, okay? Your power comes from within, not from planetary alignments. Just a little bit of factual information for you here. If you've got magical thinking going on, lose that and enter into the real world, okay? Successful people make our own luck. So here's your solar system forecast. That's where things are today. Earth is lonely on this empty side of the solar system. That's where things will be in a week. We'll have a crescent waxing moon by the 15th. And today's astronomy photo of the day is a 64-meter radio telescope that is located in Australia. It's fixed on the full moon. It has to do with the Odysseus mission, the first thing on the moon in some period of time. It was initially used to communicate with Apollo 17 back in 1972 to apod.nasa.gov if you want to check it out yourself. Next, coronal mass ejections. Those are kind of important. Here's what's been going on today. And looks pretty mild, folks. Not a lot of CMEs. So let's take a look at LASCO C2 and C3 next and see what's going on. Not a lot. Not a lot. So CME activity here, pretty mild, barely anything happening. Let's take a look at stereo A briefly as well. There's stereo A along with its difference imagery, stereo A over here on the left, and the difference imagery over there on the right. Nothing to write home about there, folks. So let's take a look at our custom coronagraphs next. These are 24-hour videos. And that is, that's Mercury and Saturn, I think, if I remember correctly. Mercury is the brighter one. Saturn is the dimmer one due to its distance. Again, CME activity here pretty mild for the past 24 hours. Doesn't look like any more earthly directed events. Here we've zoomed in a little further and added 193 angstroms running difference to the 304 angstroms STO imagery. That's what's up. And here's an even closer view before we get to filaments. And here's one more series of images. Let's blow that one up to full screen mode. Yeah, full screen mode. That's pretty sweet. That's SDO 171 angstroms running difference along with 335 angstroms raw imagery. So two different species of ionized iron there, really showing off some extended corona active regions, the lower corona, and solar filaments. Not too bad, right? Next, we'll move on to filaments. So here's Cerro Tololo's ground-based solar observatory, and we've got some on the Earth side. I mean, there you go. Some filaments on the Earth side. If you want to name some, join us over on Twitter. Two of them already have names, like that one in the lower left and like that one up in the upper right. Those are already named. Feel free to name the rest. Follow the hashtag #NameThatFilament over on x.com/smashomash. Next, the last couple of hours here, the last like 3 hours, crown filaments continuing, crown prominences, I should say, continuing at both poles. A feature you can expect to continue for the next 16 months. Here come bonus features. Charging hazards are first. We ain't got none except some minor ones in the northern Indian Ocean. Surface charging there. Low energy electrons building up on the outside of spacecraft. Next, our electron flux. That is the past 3 days. Now, wait a minute. That doesn't look right. There you go. There are the past 3 days as measured by the GOES 16 and GOES 18 using radiography from their geosynchronous orbits. They're way up there, and they're using radiography to measure it down at the F flare of the ionosphere. So they're at about 23,500 miles of altitude. Their radiography measures the F flare at about 300 kilometers of altitude. So much lower altitude there. And the X-ray flux, that's where it's designed to measure it. It becomes anomalous during space weather storms. There's the 1 year graph. You can see we had a very, very low period there, and really an electron drought lasting back until December of 2023. The electron drought continues. There's the forecast model, and it looks like NOAA's expecting even lower levels. I would tend to agree, as we're expecting a minor couple of CME impacts. Coronal mass ejections on their way to arrive late in the day tomorrow into the 3rd. Next, the layer where it's measured, the F layer. Feel free to pause the video on this frame if you're not familiar with distances in kilometers to those things. Here is the ionosphere, courtesy of Australian Government Bureau Meteorology. Complete with time and date stamps, it depicts vibrational frequency. And if that's Greek to you, don't worry, we show the anomalygram as well. There's the anomaly in megahertz from a 30-day median. We'll also show the global ionosphere nowcast depicting total electron content on the left and usable radio frequencies on the right. The anomalies are on the bottom. The raw data are on the top. And we'll close out with the latest. Saying farewell to sunspot 3590. We hope it rises again because it has been the most interesting sunspot of the cycle so far in many ways. There she goes. Tomorrow, it'll only be a little glimpse of sunspot 3590 as it gets out of sight. Anyway, here's the full disk, and it's time to move to meteorology. Let's do it. The coldest place in the world, folks. Where do you think it is? Where do you think it is? Let us know in the comments. I'll give you a moment. Go ahead. Type a comment. I'm telling you where the coldest place in the world is in 5, 4, 3, 2, 1. And it's in Antarctica. Negative 74 degrees in Antarctica in the summertime. I'll bet CNN's not going to do a story on that. Negative 74 degrees in Antarctica in summer. So there's that. North Pole is nowhere near that cold. Much warmer in the North Polar region. South Polar region, look at the cold down there. It is absolutely bonkers. Negative 72 over there. Negative 75 nearly over there. Negative 73 nearly over there. Negative 74 nearly over there. So that's not even any contest, folks. No place even close to that cold. Let's go over meteorology and get this thing onto your screens. First, surface winds of the east and your jet streams. Shout out to our viewers from Munda. Next, the jet streams and surface winds of the central world. There's the former, there's the latter. Here's the jet stream and surface wind scenario for the west. First, surface winds, and there are jet streams. Next, clouds and fog. Shout out to our viewers from all around the planet. Congratulations on realizing that the channel exists. Clouds and fog over the Americas, and another over 4 feet of snow to fall in California. That's the 3-day forecast based on the Euro model. Here's the 3-day forecast based on the GFS model. Not predicting quite as much, only 3 feet plus. So expect massive snows, folks, massive snows. That's windy.com's new snow forecast for the next 3 days, Euro model, and there is the GFS model. So a shocking amount of snow coming to California. Winter is not over, folks. Cold snap time. Here's your weather.gov map, and again, lots of blizzard warnings there shown in orange. If your location is lit, head to weather.gov and click it. Get lit. Are you lit? Is your channel lit? Is your understanding of weather information lit? Well, here comes some forecasts. So first is our pressure and precipitation map. There you go. 72-hour pressure and precipitation. Cheers. Enjoy. 72-hour accumulated positive snow depth change in inches. And like I said, 4 or 5 feet of snow coming to parts of California. Dang! Lots of snow on that map. Also, huge snows in parts of Canada. Next, our total accumulated precipitation forecast. That includes rain and snow. And that's a lot of moisture. Once again, the Pineapple Express delivering the H2O to the U.S. left coast. Last but not least, temperature anomaly forecast in degrees Celsius. And we've got some warm weather coming to the east. So set up your bike rides for Sunday, folks. And, of course, let us know in the comments what your exciting warm weather weekend plans are. Look at that warm air coming in, folks. Yeah, good times. Next, lightning. And we do have some lightning here in the southeastern U.S. Let's see if we have any active cells at the moment. Do we have terrestrial strikes? What do you got? Doesn't look like it. What about around Auburn, Alabama there? Or is that Mississippi? That is Alabama. We do have some minor thunderstorm activity in there. So that's what's going on. It's a real-time lightning map from lightningmaps.org. If you've never checked it out, next time you hear thunder, if you've got sensors near you, it's highly recommended. If not, don't. I don't care. We'll close out with U.S. Doppler radar. There's a close-up of those storms in Alabama moving into Georgia. The heaviest weather is just about to arrive there, Georgians. And let us know in the comments if you know what people from Michigan are called. You know what people from Michigan are called, folks? They're called Michiganders. Yeah, Michiganders. What's good for the goose is good for the Michigander. So, anyway, there's the full 50-state view. We're going to focus on the lower 48 view and close this thing out. U.S. Doppler radar depicts vertical motion in the air column. Slow-moving systems there in the southeast. Here is clouds and fog. From the satellite map, the shortwave radiation map, the 3.9 micrometers, part of the infrared, part of the NASA GOES interactive weather satellite suite. And there is the water vapor map, a large band of dry mass of air there stretching all the way from San Diego all the way to Lake Erie. From San Diego to Lake Erie there, a big band of dry mass of air. So pressure gradients are what's creating that moisture, that precipitation there, and the boundary there is moving across Tennessee and Kentucky at the moment. Here's your recap. U.S. Doppler radar, that's vertical motion in the air column. When calibrated right, it will show you precipitation. That's clouds and fog. It'll show you clouds and fog even at nighttime. And that is water vapor. It'll show you the dry air, the moist air, and everything in between when your Doppler is unclear. Try the water vapor map. Anyway, I'm trying to log out, so we'll see you soon. In the meantime, may that solar wind be at your back while I go back to the bunker again. I'm always climbing down in here and then back out again.